Welcome to this explainer. Today, we're tackling something that totally flips how we usually think about artificial intelligence. We hear a ton about the flashy frontier models, the massive names constantly making headlines. But the true battleground in AI, it actually isn't those models at all. It's the hidden infrastructure running right underneath them, the unseen architecture that literally makes the magic happen.
So, let's start with a question that might sound a little controversial. What if the base AI model doesn't actually matter as much as we think it does? We've all been kind of conditioned to believe that bigger models automatically equal better AI. But today, we're going to dive way below the surface of the industry to see exactly why that assumption is fundamentally changing. To really understand this shift, we've got to define the AI plumbing. We're talking about the underlying data systems, the knowledge layers, and the orchestration frameworks that actively feed and manage these AI workloads. Think of it like the foundation of a massive skyscraper. You can't see it from the street, but this exact layer is where massive, game-changing performance gains are being unlocked right now. And just to give you a sense of scale, the tech industry is literally pouring billions of dollars into this invisible plumbing, moving yottabytes of data every single day just to keep those famous models fed. It's a colossal undertaking. But as you'll see in a minute, it's also exactly where some truly terrifying security risks are hiding. Section 1. Beating the biggest models. All right, let's look at our first example of this plumbing's incredible power and how specialized knowledge layers are actively beating the biggest names in tech. Take a tool like Pinecone Nexus. This is a knowledge engine. Its entire job is to take a company's messy internal data and workflows and turn them into governed, agent-ready knowledge that an AI can access with just a single call. Think about real-world enterprise tasks like customer service automation. In those scenarios, getting the facts absolutely right and strictly adhering to company policy matters way more than just raw model size. Nexus optimizes for that kind of multi-step reasoning and strict policy adherence. And wow, the results are staggering. On its debut on a highly demanding open benchmark for enterprise AI agents, an agent built on Nexus posted the top score. It solved roughly 47% of the tasks. Now, to understand why that's a huge deal, you got to know what this benchmark actually tests. It isn't just answering simple trivia. It requires pulling disparate data from multiple databases, writing and executing code on the fly, and navigating really complex corporate policies without hallucinating. It is incredibly difficult. Yet, this specialized agent actually outperformed agents built directly on the leading frontier models. The knowledge layer, not a bigger model, took the crown. And the efficiency numbers? Just as notable. This Nexus-powered agent ran at 74% less cost per task compared to a frontier model agent that didn't have a dedicated knowledge layer. I mean, a 74% cost reduction is exactly the kind of number that makes a CFO weep with joy, right? That is a massive operational saving for literally any business trying to scale AI across their entire workforce.
But look what happens when you combine the two. When you pair this specialized knowledge layer with a strong frontier model, accuracy gets boosted by an additional 12%, while the overall costs are slashed by a massive 80%. It does this by basically halving the number of tool and model calls the system actually needs to make to get the right answer. The AI doesn't have to guess or search blindly anymore. The plumbing just delivers exactly what it needs.
So, what does this all mean? Well, it suggests a massive shift in the industry. The data and retrieval infrastructure feeding an AI agent is increasingly determining its real-world performance, even more than the base model itself. This completely challenges the idea that frontier AI labs are the only ones who are going to capture the value of enterprise agents. It opens up this huge space for specialized infrastructure vendors to compete head-to-head on actual results, rather than just coasting on brand name recognition. But there is a very dark side to this infrastructure boom. We have the promise of scale, the incredible efficiency and accuracy we literally just looked at. But we also have the price of scale. Because while AI plumbing offers this incredible power, as it scales up so rapidly, it introduces a massive, rapidly growing attack surface.
Section 2. The dangerous Ray Flaw.
This brings us to the core focus of today's explainer, a terrifyingly critical vulnerability discovered in a foundational piece of infrastructure used by some of the biggest tech names in the world. To really grasp the danger here, you need to understand what Ray actually is. Ray is a widely used open-source framework. Its job is to take massive machine learning workloads, things like training a new large language model or running thousands of simultaneous user prompts, and distribute them across many, many machines at once. Distributing workloads isn't just a nice-to-have, it's physically required because literally no single server on Earth can hold these massive models. Ray orchestrates these massive compute clusters so they act as one giant brain. And because it's so incredibly effective, Ray's market share is staggering. It powers the infrastructure at major cloud providers, Fortune 500 consumer tech companies, and top AI labs alike. If Ray is compromised, the very bedrock of modern AI is compromised.
Let's walk through the chilling reality of how this exploit actually works. We start with step 1, an unpatched Ray framework. Step 2 is where the absolute nightmare happens, a critical remote code execution vulnerability. Now, remote code execution, that is essentially the holy grail for a hacker. They don't need physical access to your servers. They don't even need to trick an employee with some complex phishing scheme or steal a password. They can simply walk right in and remotely execute their own malicious commands directly onto a machine running Ray. Which leads us to step 3. The attacker potentially gains total unfettered control over the entire compute cluster running those vital AI workloads. Practically speaking, this means they could steal highly proprietary training data, silently poison models to give incorrect answers, or just hijack millions of dollars worth of expensive GPUs to mine cryptocurrency. They own the engine.
And this isn't just theoretical. The United States government cybersecurity agency, CISA, officially added this critical vulnerability in Ray to its list of known exploited vulnerabilities. Listen, they do not add things to this list lightly. It requires rock-solid evidence of active exploitation happening out in the wild. They took this so seriously that federal civilian agencies were given only a matter of days to patch it under a strict mandate. And remember, around this exact same time, a related monitoring tool vulnerability was patched by a major software vendor, making it an incredibly tense, high-stakes few weeks for AI security teams everywhere. The federal government was essentially sounding a massive alarm.
The real-world stakes here are incredibly concrete. If you are an organization running distributed AI training or inference at scale, and your patching lags behind, you are a potential target. If your company is deploying AI at scale, you really have to ask yourself, is your security team patching the orchestration layer as fast as your developers are building on it? This highlights a much broader, highly concerning pattern. Security work on the orchestration layer simply hasn't kept pace with the explosive rate of AI adoption. Everyone was focused on the shiny new models, while the foundational plumbing was basically left completely exposed.
Section 3. The next AI battleground.
So, we're looking at a dual reality here. Incredible model-beating power on one hand, and catastrophic cluster-level security risks on the other. Over the next 3 to 6 months, you can expect some massive shifts in response to this. First, enterprises will start benchmarking their full agent stack, knowledge layers included, instead of just comparing base models. Second, expect intense scrutiny of open-source AI infrastructure. The business impact goes way beyond just one framework. It puts huge pressure on cloud providers and labs to harden the plumbing underneath their models, because ultimately, a compromised cluster undermines every single application running on it. Securing a massive AI model is entirely useless if the cluster it runs on has an open backdoor. We're going to see researchers and government agencies shifting major attention right toward framework-level risk mitigation.
Which leaves us with this final thought to consider. We interact with AI constantly, trusting the outputs of these massive systems for our businesses, our research, and our daily lives. But as we now know, real performance and real danger don't actually live in the AI models themselves. They live in the infrastructure. So how secure is the invisible plumbing running the models you trust every single day? It's a question the entire tech industry is suddenly racing to answer.